Question 4. So for part 1 we just use the factor theorem. So if x minus 2 is going to be a factor, when we substitute 2 into the function we should get 0. So we're finding f of 2, so that's 2 cubed minus 2 squared plus 2 minus 6. That indeed equals 0, so therefore x minus 2 is a factor. The only bit to be careful of here, if we're trying to show that x minus 2 is a factor, remember to substitute plus 2 into the function. Now that we've established that x minus 2 is a factor, for part 2 we can just do our long algebraic division. So we're going to divide this by x minus 2. So remember how this works. You say to yourself, x times what gives you x cubed, and that's x squared. So x squared times x is x cubed, and x squared times minus 2 is minus 2x. So we take that away from each other, so we have x cubed minus x cubed, which is nothing, minus x squared minus 2x squared is actually adding 2x squared, and minus x squared plus 2x squared is plus x squared. We'll then draw down our plus x and we start our second cycle. X times what gives us x squared? Well, that's plus x up here. And then it's x times x is our x squared, and x times our minus 2 is our minus 2x. We then take them away from each other. X squared minus x squared is nothing. X minus 2x is x plus 2x, which is 3x. We then draw down our minus 6, and we start our third cycle. We say to ourselves, x times what gives us... what have we got to do here? Yes, we've got to say x times what gives us 3x. Well, it's x times plus 3. So we put our plus 3 up here. Then it's 3 times x and 3 times minus 2, which gives us our 3x minus 6. And obviously 3x minus 6 minus 3x minus 6 equals 0. And we're expecting no remainder because x minus 2 is a factor. So basically we're saying this divided by this equals this. Or in other words, this times this equals this. So we can set our cubic as being this times this. So at this point we've partially factorized. Okay, now I need to go and factorize this. Well, this doesn't factor. In fact, there are no real solutions to this. A is 1, B is 1, C is 3. Remembering A is the coefficient of the x squared, B is the coefficient of x, and C is the number on the end. And if you look at the discriminant b squared minus 4ac, we indeed get a negative here. And if the discriminant is negative, we're getting no real solutions from this quadratic. So in fact our only solution is coming from x minus 2, which is 2. So therefore we've shown that the function only has one real root, which is when x equals 2.